In this lesson, we will prove the fundamental law of trigonometry, and then we will deduce other laws from this fundamental law. For this purpose, we are going to consider a unit circle. So consider a unit circle with point A, making central angle alpha at the center of circle. So if this point A is here, if we consider that this is the point A and here is the origin, then this line OA makes this angle, which we have assumed that this is alpha. Similarly, we consider another point. We consider other point B and C such that they make angle beta and theta respectively. At O. So now here is the point B. This is point B, and if we take this line connecting O to B, and this angle at the center is considered as beta, and then we take another point C right here, which is this point. This line OC is line OC, and this angle is equal to theta. Then obviously the angle which AOB is making, like at the center here, that is angle alpha minus beta. That is alpha minus beta. The central angle, we consider theta. So that this angle is equal to theta is equal to alpha minus beta. Alpha minus beta, where angle AOB is equal to alpha minus beta. So this is the angle which ray OA and OB are making among themselves, while alpha is the angle from x-axis being made with OA, and beta is the angle which OB is making with x-axis. So now we consider another point D on x-axis. Because it is unit circle, therefore OD is equal to 1. If we consider another point D at intersection of x-axis and the circle, such that the length OD is equal to 1 because of unit circle. Then what will be coordinates of D? The coordinates of D will be equal to 1, 0 because D is just on x-axis, its height is 0, and because it's a point on the unit circle, therefore its radius is equal to 1 and the coordinates of D are 1, 0. Now obviously let's consider that this was the point A. We are taking it just out of the circle so that there is not too much mess in the circle. If this was the point A, which we considered that it was making an angle alpha at the center of the circle, if we would have considered coordinates of A as x, y, then this will be for sure y, height, and the length of the base would be x. From this triangle, let's name this as something, another point called P, and this is already O. Then from triangle AOP, what would be cos of alpha and what will be sine of alpha? Cos of alpha would be equal to x over 1 because it's a unit circle. The OA is equal to 1, and similarly sine alpha is equal to y over 1. If that is the case, this means then x is equal to cos alpha and y is equal to sine alpha. So what we are trying to prove here is that the coordinates of A would be equal to cos of alpha sine alpha, where alpha is the angle which OA is making with x-axis. So keeping this in mind, we can pretty much write coordinates of A like this. Coordinates of A would be cos alpha sine alpha because OA is making an angle of alpha with x-axis. And coordinates of B would be cos beta sine beta because this is making an angle of beta with x-axis. So this is how we reach to the point, and the coordinates of C in that case would be cos of alpha minus beta and sine of alpha minus beta. Sine of alpha minus beta. The reason, because we already assumed that theta is equal to alpha minus beta. So from this point, we can see that the triangle AOB, we observe that triangle AOB is congruent to triangle COD, is congruent to angle COD. The reason, because central angle is same and both sides of triangle OA and OB, they are both 1, 1 in length because they are radius of the unit circle. Similarly, OC and OD are equal to 1 because for triangle AOB, OA is equal to OB and both are equal to 1, and for triangle COD, OC is equal to OD and both are equal to 1. Also, we assumed we assumed that theta is equal to alpha minus beta. So when two sides are equal to the corresponding equal sides of another triangle and their included angle is also equal, the triangles are both similar. If that is the case, then AB, this means AB is equal to CD. And if AB is equal to CD in length, then obviously their square must be equal as well. This means AB square is equal to CD square as well. And now if we apply the distance formula, if we have 2 points, remember this, if we have 2 points L with coordinates x1, y1 and another M with coordinates x2, y2, then the distance between them, LM, if you remember from the distance formula, is equal to x2 minus x1 square plus y2 minus y1 square. We apply this formula to calculate the distance between 2 points. So using that distance formula, now AB will be equal to, because the coordinates of A are cos alpha, sine alpha, and coordinates of B are cos beta, sine beta, therefore the AB would be equal to cos alpha minus cos beta whole square plus sine alpha minus sine beta whole square equal to 1 minus cos of alpha minus beta whole square plus 0 minus sine of alpha minus beta whole square. If that is the case, let's just expand squares on both sides. So this side will become cos square alpha plus cos square beta minus 2 cos alpha cos beta plus sine square alpha plus sine square beta minus 2 sine alpha sine beta equal to, so this would be 1 plus cos square alpha minus beta minus 2 cos alpha minus beta. And now this will be on the next line plus sine square alpha minus beta. And if we apply the fundamental trigonometric identity, that is cos square alpha and sine square alpha, let's get them together. This will be like cos square alpha plus sine square alpha, and also cos square beta and sine square beta together plus cos square beta plus sine square beta, and if we take common minus 2, that would be like cos of alpha cos beta plus sine of alpha sine beta equal to 1 plus, we have cos square alpha minus beta, cos square alpha minus beta plus sine square alpha minus beta, alpha minus beta, and we have to write on the next line, but we are left with only one term, which is minus 2 cos of alpha minus beta. So now this cos square, since cos square theta plus sine square theta is equal to 1, that is fundamental trigonometric identity. This means here 1 plus another 1 here minus 2 cos of alpha cos beta plus sine alpha sine beta is equal to 1 plus 1 again, because cos square alpha minus beta plus sine square alpha minus beta for the same reason is again equal to 1 due to fundamental trigonometric identity. So 1 plus 1 minus 2 cos of alpha minus beta, and this gives us in 2 minus 2 time cos of alpha cos beta plus sine of alpha sine beta equal to 2 minus 2 cos of alpha minus beta. So comparing and cancellation, we get cos of alpha minus beta is equal to cos of alpha cos beta plus sine alpha sine beta, which is called the fundamental law of trigonometry, which is known as fundamental law of trigonometry. And all the other laws can be derived from this law. So let's consider drawing the second law from this law, and all what we got to do is replace beta by minus beta in this fundamental law of trigonometry, and let's call this as 1. Replace beta by minus beta. So if that is the case, then this would be equal to cos of alpha minus, instead of beta, this time we will have minus beta, equal to cos of alpha cos of minus beta plus sine alpha and sine of minus beta. And since cos beta or cos theta is even function and sine theta is odd function, means cos of minus theta is equal to cos theta, but sine of minus theta is equal to minus sine theta. Remember, cos is even function and sine is odd function. So this gives us cos of alpha plus beta equal to cos of alpha cos beta instead of minus beta. And that sine minus beta will throw out the negative sign in front of that term. This will become minus sine alpha sine beta. And this is the second law which we are going to use extensively while doing questions. So mark this down as well, and let's call this as second. So if this is second, now for alpha, put alpha equal to pi by 2 plus alpha. Pi by 2 plus alpha. So alpha and beta are representative angle. They could be any angle. So this means we have cos of pi by 2 plus alpha plus beta equal to cos of, instead of alpha, now it will be pi by 2 plus alpha into cos of beta minus sine of pi by 2 plus alpha into sine of beta. But because of this arrangement, that if we have a unit circle, and this is the line indicating theta is equal to pi by 2, we know that all trigonometric ratios are positive, sine is positive, tan is positive, and cos is positive in fourth quadrant. This is quadrant 1, this is second quadrant, this is third quadrant, and this is fourth quadrant. Although we are going to prove these in next lesson, but these things could be remembered, that the value of cos of pi by 2 plus theta, because this angle pi by 2 plus theta falls in the second quadrant where the value of cos is negative, and always while crossing pi by 2, the cos will change into sine, sine will change into cos. So cos of pi by 2 minus plus theta is equal to minus sine of theta. We are going to prove these using these laws in next lesson, but for now we can write these as cos of pi by 2 plus theta, and similarly sine of pi by 2 plus theta. Since pi by 2 plus theta is an angle of the second quadrant where the value of sine is positive, therefore this is going to be equal to cos of theta, and we can comfortably use these values, and we will be using these in our coming exercises and in coming lessons as well. So this would be cos of pi by 2 plus alpha plus beta here, and equal to this cos of pi by 2 plus alpha will become minus sine of alpha into cos of beta minus cos of alpha into sine beta. This means this will become equal to sine of alpha plus beta. Because of pi by 2, this will become sine of alpha plus beta. This is equal to, and the value of cos in second quadrant is negative, therefore we are going to place negative sign here, is equal to minus sine of alpha cos beta, and if we take this minus common, this will become plus cos of alpha sine beta. Now if make the cancellation on both sides of the negative sign, this means that we have proved sine of alpha plus beta equal to sine of alpha cos beta plus cos alpha sine beta. So this is third law that we have proved, and we will be using this a lot in the coming exercises as well. So let's use this. And now replace beta by minus beta. Replace beta by minus beta in this, and if we do that, this means we have sine of alpha, instead of plus beta, now we have minus beta, because we have made that replacement everywhere in the formula. This will be equal to sine of alpha cos of minus beta plus cos alpha sine of minus beta, and now this will become sine of alpha minus beta is equal to sine alpha cos beta sine alpha cos beta. Again, because cos is an even function, so cos of minus beta is equal to cos of beta. And sine of minus beta being odd function throws out minus in front of the term, so this means this will be equal to cos alpha sine beta. We have a couple of more laws to prove, but we will prove those in the next lesson based upon these values. So now we are going to end this lesson, and we'll see you in the next lesson again.